In this video we look at multiplying and dividing monomials. Before we do that, we should maybe talk a little bit about what a monomial is. Earlier in the semester we talked about adding 3x plus 2y. We talked about this idea of collecting like terms. Now in this case these are not like terms, so we can't collect them. The important thing here though is to note that we would call this a term and we would call this another term. So we've talked about this before, but those are two terms. They're separated terms. They're separated by plus and minus signs, so there's a plus sign in here. This gives us two terms right here. So a monomial is just a single-termed expression. So here are some examples of monomials. So 3x by itself would be a monomial. 2y would be a monomial. It doesn't have to be a simple expression like this. It could be much more complex. So for example, negative 7x squared y cubed z would be an example of a monomial. So those are all monomials, and what we're going to do today is we're going to talk about multiplying and dividing those monomials. So let's start with 3x times 2y. 3x times 2y. I'm just going to show the multiplication by separating the two terms with brackets here. So the one term is in brackets, multiplied by the other term in brackets. The understood operation here is multiplication. Now it's important for you to remember that multiplication is associative. That means it doesn't matter what order we do the multiplication it is in. So for example, 3 times 4, I'll just use the dot for the multiplication symbol here, is the same as 4 times 3. So we can use that same property here to rearrange this expression. So what I'm going to do is I'm just going to change the order. I'm still going to do a whole bunch of multiplying. And again, remember this means 3 times x times 2 times y. So I'm just going to, in fact, let's write it like that. 3 times x times 2 times y. And just like we did up here with the 3 times 4 example, let's rewrite this so that the coefficients or the numbered portions are together multiplied. So we'll do the 3 times the 2 times the x times the y. Well, we can simplify this. We know what 3 times 2 is. That's fairly straightforward. That's 6. And then we still know that we have to multiply it by x. We don't know what x is, and we don't know what y is, so we just leave it at that. So that's the goal here, is to multiply these monomials and get a, in this case, a single expression here. So I want to talk a little bit about what happens if we get into something that's maybe a little more challenging, a little more difficult. And you've already seen some examples like this earlier on. So some of the work that we did earlier on, for example, talked about multiplying x by x. Well, what do you get when you multiply x by x? And hopefully you'll remember from the work that we did earlier on that x times x, a short way to write that is just x squared. Now one of the things that you may not notice here is that there is one x multiplied here by another x here. We often don't write this in, but I'm going to write it in just to show you that this means x to the exponent of 1. There is 1x multiplied by itself here, there's 1x multiplied by itself here, and an easier way to write that, is to have 1x multiplied by itself twice. That's what this 2 here means. And we've kind of talked about some of that already. So what we want to look at today is what happens when we multiply multiple x's together. So for example, let's have a look at taking x squared and multiplying that by, well, let's make this a little bit more challenging. Let's call this x cubed. I'm going to write this out the long way so you can see what it looks like. X squared is really just x multiplied by itself twice. So there's x times x. So this is just x squared right here. Just written in a long way. And you might wonder, why are we writing it out in a long way? I think it's going to be helpful to see what we need to do here. And then we need to multiply that x squared by x cubed. Well, x cubed, the x with the 3, as the exponent, just means multiply x by itself 3 times. So here's our x cubed. And we can rewrite this in a shorter way by counting how many x's there are. Well, there are 1, 2, 3, 4, 5 x's that are multiplied here. Well, a short way to write x multiplied by itself 5 times is to write x to the exponent 5. Hopefully you can look here and see how to go right from here to here. Take a moment and think about, well, what could we do instead of doing this intermediate step here? What's a shorter way to go from here to here? Well, notice that there were 2 x's in the x squared and 3 x's in the x cubed. If we add those exponents together, we get the exponent here in the answer. So, the idea behind multiplying monomials is that we multiply the coefficients. We'll do a couple of examples so you can see this, but we'll multiply the coefficients together, and then we'll multiply the powers that have the same base. So that rule that we just talked about adding the exponents only works if we're multiplying the same base. And the way that we multiply powers with the same base is by keeping the base and adding the exponents. Let's have a look at some examples. So let's try a couple here. So here's example number, we'll call it A, example A. In fact, the goal here is to multiply these since that's what we're looking at. And our first example will be 3x squared times 4x cubed. So when we rewrite, what we could do here is we could rewrite this, and I'll do this a long way and then we can talk a little bit about doing the short way. Again, we could rewrite the multiplication just like we did earlier. We could take the 3 and multiply it by the 4, and then multiply that by x squared, and multiply that by x cubed. So here's the shortcut here is to just go right to multiplying the coefficients. So the coefficient was here and here. Multiply the coefficients, we get a total of 12. And then we multiply powers with the same base. These two powers have the same base, so we multiply them by keeping the base and adding the exponents. So 3x squared times 4x cubed gives us 12x to the 5. Let's have a look at a slightly different example. Should be able to fit it over here. So that slightly different example is going to have us multiplying 3xy times negative 4x squared. So same idea. I'll skip the intermediate step this time. We're going to multiply the coefficients together. 3 times negative 4 is negative 12. And then we're going to multiply powers with the same base. So the x is a power here, and it has the same base as this x squared. So we want to multiply these two powers with the same base. Don't forget, if there is no exponent written here, the understood exponent is a 1. And the way that we multiply the powers with the same base is we keep the base. So we're going to have an x here. We have 1x here, 2 other x's over here that are multiplied together, and we multiply all those together, we get x cubed. And then the y is just off all by itself. There are no other y's to multiply by, so we just leave it here and have the multiplication, by y. So that's how we can multiply monomials. Let's have a look at dividing monomials. So dividing monomials, again, I'm going to start with a basic example and we'll kind of work progress to harder examples. So I'm going to start with 5x squared divided by 5x. Again, without talking about any rules yet, I want you to think about how we can sort of manipulate this. One of the things that you'll notice here is that we have 5 divided by 5. So we can actually separate that into its own little fraction, own little division statement. 5 divided by 5, and then we also have an x squared divided by x. Well, we know that 5 divided by 5 is just 1, and x squared divided by x. I'm just going to put an x squared here as x times x. So that's our x squared, and we want to divide that by x. So if you look here, we can actually kind of do some division and do this division right here. So peel these x's off, x divided by x is a 1, so this can be replaced by a 1, so we get 1 times x, which just gives us x. So it's very similar to the multiplication example that we did earlier. A little bit maybe harder to follow along at the beginning, but the procedure is very similar to how we did it before. So again, here are the rules for dividing monomials. We divide the coefficients just like we did back here. We divided the numeric parts. We divided 5 by 5. So we did that part. And then we divide powers with the same base by keeping the base and subtracting the exponents. So again, let's do a couple of examples so you can see what this looks like. So here's our example. We're going to divide. And we'll start with 12x cubed y squared divided by 4x y. So again, we're going to start by dividing the coefficients. So here are the coefficients. We're going to go ahead and do this division. What's 12 divided by 4? So 12 divided by 4 is 3. So we did that, and next up we're going to divide powers with the same base. They have to have the same base. So here's a base of x, here's a base of x. So we can go ahead and divide these powers. Now it's important to remember that this x with no exponent has an understood exponent of 1. So we keep the base is x, and we subtract the exponents. I'm going to write that subtraction in, so we don't lose things. So we took the 3 from here and the 1 from over here. Next set of common bases are the y's. We have a y squared, so we keep the base and we subtract the exponents for a y squared divided by y. So y squared, and we're going to subtract 1 because the understood exponent on this y is a 1. Let's simplify that a little bit. 3 minus 1 is 2. 2 minus 1 is 1. We often don't write the 1 as an exponent, so this would kind of simplify down to 3x squared y. Alright, let's do another example. Possibly a more challenging example, a trickier example in a sense, because if you're not careful, it's easy to make a common mistake here. So I'm going to start with 3a cubed b to the 4 divided by 6a squared b. Now, again, we're going to follow the procedure here. The procedure is to divide the coefficients. So 3 divided by 6. It's very common for students to say that 3 divided by 6 is 2. But remember that 6 divided by 3 is 2. We need to do 3 divided by 6. Well, 3 can't be divided evenly by 6, but what we can do is we can turn that into a fraction. That fraction of 3 divided by 6 looks like this. It's a fraction that we can reduce by dividing both the numerator and the denominator by 3, giving us a half. So this fraction really just simplifies to 1/2. So I'm going to write that in. So 1/2. So we've divided the coefficients. Next we're going to divide the powers with the same base. Let's go with the a's here. So the rule for dividing the powers with the same base is we keep the base, and we're going to do this in the numerator. So a to the 3 minus 2, keep the base, subtract the exponents. And then we're going to get a b to the 4 minus 1. Again, don't forget this b has an exponent of 1. And then we can simplify from here. We don't need the 1 in front. So this simplifies to a to the 1, b to the 3, all over 2. And again, typically we wouldn't write that a to the 1 in there. We would write that as ab cubed divided by 2. So that's a not so short video on how to multiply and divide monomials.